Thank you for attending the executive webinar session at American Workflows Enterprise Software Company. American Workflows Enterprise Software Company is a world-class enterprise software publishing and enterprise software distribution company based in New York. American Workflows Enterprise Software Company is active nationally and internationally. For more information about American Workflows Enterprise Software Company and its enterprise software products, please visit the corporate website at www.americanworkflows.com. To get the executive webinar session started, I would like to invite the managing partner of American Workflows Enterprise Software Company, Mr. Kevin Devisiglu. Kevin, floor is yours. Thank you.
Thank you. Thank you very much for the introductions. My name is Kevin Deveci, and I am the managing partner of American Workflows Enterprise Software Company, also known as AWF. Today, in this executive webinar session, we'll talk about total productive maintenance management practices in manufacturing industry, and also we'll have an introduction to America P3M AI-powered machine health condition monitoring, predictive machine maintenance, OEE, and energy management software system. For today's session, we have a panel, and today we'll cover the fundamentals of total productive maintenance management practices, as well as we'll perform a demonstration of America P3M software system. So you can see AI working to predict the machine health condition, and also you can take next steps with help of the software in a predictive manner to perform machine maintenance management before anything breaks down. So today we'll cover all of these. Today with us, we have Batu from our pre-sales software specialist team. Batu will perform demonstration, and also we'll learn about the fundamentals of total productive maintenance management from Ron Loveland, President of Summit Safety and Efficiency. Before further ado, I'd like to invite Ron to our virtual stage, and let's learn the fundamentals of total productive maintenance management, the definition of it, the importance of it, and some practical information based on his insights. Ron, floor is yours. Please tell us about total productive maintenance management. Thank you very much.
Okay, well, thank you, Kevin, for inviting me to chat a little bit about some lean techniques that we've been employing to help our manufacturing customers here in the New York metro area. This is called total productive maintenance, which we don't always talk about, but you know, it's all about Murphy's Law, right? Well, whenever you need it the worst, something's going to go wrong, right? So you know, it's the end of the month, you're trying to make production, or you have a urgent requirement to get out, and all of a sudden, boom, you have a machine breakdown, and man, you're kicking yourself that you didn't do more to make sure that things went well. So today we're going to talk about techniques that have been developed by the Toyota production system, as well as others in Japan, to avoid that last minute oops breakdown that we all seem to run into. So just a little introduction of who Summit is. We are a manufacturing consulting firm. We do safety, quality, and efficiency, and our target really focuses on manufacturers, distributors, and we also help construction, especially in the safety areas. So what are we going to talk about today? We're going to talk about maintenance, right? For a lot of you, you have your own car, you have your own equipment, and you got to keep that top notch. So we're talking about maintenance, the types of maintenance, total productive maintenance, which is really focused on manufacturing, history of TPM, the TPM pillars, 6 big losses, and goals and benefits of using total productive maintenance. All right, so what do we mean by maintenance? You know, really, let me just get my screen so I can see what's happening here. There we go. You know, it's types of maintenance. You either fix it when it breaks, right? Which most of us do, right? You're driving down the road, your car's all packed, you're full of your luggage and everything, going to the lake or going to a vacation, and all of a sudden, boom, you get a flat tire, right? So you got to deal with it when it happens to you. The other approach, which I recommend is a little bit smarter, is the preventative maintenance, right? So you take a proactive approach, you try to avoid those problems that seem to keep coming up, and then avoid that last minute driving rain or in a snowstorm or whatever it is. You gotta get out and change your tire. Much better to be ahead of it to make sure that that doesn't happen to you. All right, and then there's predictive maintenance, right? Just an attempt to determine the best way to predict when things are going to happen. And it's like, well, how do I know that, right? Well, let's take the automotive tire situation, right? If you keep your tires well maintained, you inspect them routinely, then you're gonna know that after 40, 50,000 miles, whatever they're rated for, that hey, it's time for some new tires. And predictive maintenance is one of the 4 tactical approaches that we could take. It's either on fail, right? It happens in the middle of a snowstorm or rainstorm. There's a fixed time, that, okay, I have, tires that are rated for 50,000 miles. So probably around 30,000, I should be checking out if I haven't done that initially. There's predictive and design out, sorry. So how many people have run flats, right? I happen to have run flats on mine. So even if you do, run over a nail or, pick up something, you can still make it to the maintenance place and get your tires changed if you have run flats. So that's kind of a design, new design technique that has been happening. You have an optimized maintenance plan, and you may have a distribution, a mix of these different techniques to make sure that your equipment is running top notch and you don't have that last minute, Murphy's Law issue that kills you at the end of the month, or with a critical delivery you have to make. And if you look at this chart here from ASME, it kind of gives you kind of a cost of what it costs you to take different approaches to maintenance, right? So if you just wait for breakdown, relatively speaking, that's going to cost you about $55. If you plan ahead, it's 30. And if you use predictive, if you use predictive maintenance, it's down around $7, comparative cost. So it certainly pays, even though it's a little bit more investment of time and money to do that ahead of time. It's better off in the long run. All right, so predictive maintenance is really the most attractive, and it's the one that you really should be using. It takes a look at avoiding that severe damage. That's the other problem with if you're not paying attention and you just wait for the things to break. If that machine breaks, what else is going to break with it, right? So a lot of times, if you have a catastrophic issue with the machine that breaks, it breaks other components, and all of a sudden you got a much bigger problem than if you had spent time ahead of time to make sure you get that maintenance done. And it's really a team approach with predictive maintenance. Is everybody from the operator through the facility maintenance, through the engineers, all work together to make this work well. You take a look at condition monitoring, right? So if you see that you've got some wear and tear, or you got some poor performance or reduced performance in a piece of equipment, you have to take that into effect as well to predict where things are going to break down. A lot of times, again, if you go back to the car situation, right? If you hear a weird noise, right? A matter of fact, interesting story is just last week, my wife was doing the laundry with the dryer, and all of a sudden you're hearing this horrible squeak, and you're saying, "What's going on?" I mean, we could have just let it keep on going until the belt snapped, and then we'd have no dryer. So instead, that was an indication that we needed to change the belt, and we got that repaired, and we're back in business. So our 15-year-old dryers keep on trucking, but that kind of gives you an idea of the monitoring, condition monitoring, to make sure you pay attention to those weird sounds that you may hear in your equipment. All right, so again, total productive maintenance is a company-wide strategy. You take a systemic approach, and you basically look at the science approach to maintaining your equipment, as opposed to rolling the dice and hoping for the best. Again, company-wide strategy and a systematic approach that includes everybody in the process to make sure it's working right. So here's a little bit of, is this going on in your facility, right? Maintenance is fighting against operations, is fighting against engineering. Operations just want to crank it out, man. Let's just keep on going. We don't have time to stop and fix it and do preventive maintenance. The maintenance guys are saying, man, if you don't fix it, if you don't stop operations, give me time to fix it, you're going to have a problem. So let's work together to get that. And engineering, a lot of times, there's a design of the equipment that you could put in place to avoid these breakdowns. Again, here's you want to avoid the downtime, the defects. If your equipment is not performing to top quality, you're not going to be making good parts, right? So you're going to have issues going on there. So before there was you basically you're fighting against each other between maintenance, operations, and engineering. And really what TPN seeks to do is to get everybody working together. Operations has to give up some time to get the maintenance done. Engineering is going to take a look at your processes and your equipment to maybe design out some of those potential issues that you have with maintenance breakdowns. All right, so once again, company-wide efforts, everybody's working together. It's productive. There are some actions that you could do while production is going on, right? You can still take a look at the site gauges, make sure that the fluid levels are where they need to be. Maybe there's some temperature gauges that you're looking at as well. So, if something is identified, and typically it's the operator that's right there that sees it, they alert the maintenance crew and keep it in good condition. So here's a little bit of history. It came out of Nippon Denso, a Japanese manufacturer that came up with this concept. It really makes a lot of sense, again, to work together, total team from operator through engineering and maintenance to make sure that equipment is doing well. So let's talk about some of the pillars of TPM, total productive maintenance. You got autonomous maintenance, Kaizen, planned maintenance, quality maintenance, training, offices, right? So a lot of times, we go into companies that are saying, man, we're struggling with efficiencies, and a lot of times the root is in the office. If the people on the floor, the equipment operators are not getting the information that they need from the office, then it impacts not only their production but as well as their maintenance. And then finally, very important for all of us these days is safety, health, and environmental issues. So we have to keep all of those in mind as we're going through this process. All right, pillar number one is 5S. For those who are not familiar with that, that's a lean technique that basically says sort, set in order, shine, and standardize and sustain. You got to look at getting rid of the stuff that's in the way. I've been to far too many companies where they have old equipment, they have old piles of product in the way. You got to get that all sorted out. Get rid of the stuff that you don't need anymore, that you're not working anymore, and then clean it up. Standardize, make sure that you have, a standard process so everybody sees that that's the way it's supposed to be in my operation. And then, of course, the biggest thing is sustaining, right? So work to sustain those those efforts. All right, pillar number 2 is autonomous maintenance, which basically talks about, the person, the operator at the machine who's looking at what's going on. They're really your first line of defense, and it's not the attitude of, hey, I'm the operator, I'll let maintenance fix it. It's, hey, I'm the operator, I got to make sure my equipment works. Just like you as a car owner, you got to change the oil, you got to bring it back to the shop if it needs, periodic maintenance. So, the operators need to be part of the team that keeps it going. So initial cleaning, eliminating sources of contamination. This really talks about, 5S in the general area. Have a checklist of cleaning to make sure, at the end of the day, at the end of the week, whatever it might be, that you're making sure that you're keeping it clean and you're keeping it operating well. General inspection, autonomous inspection, and just general housekeeping to make sure it goes. So this really talks about the operator's role in total productive maintenance. Kaizen, right? So number 3 is talking about Kaizen. Did I miss one? Yeah, no, I didn't. We have to continuously improve, right? Just like Chris was talking about earlier. I love that video that you put together, Chris, with the baker. We're always constantly changing and improving. So think about ways that you can work together as a team to conduct Kaizens and can continuously improve. All right, I got a chat here. Let me just see what we're saying in the chats. Okay, you got it, man. So let's talk about planned maintenance, right? So, with planned maintenance, you're trying to eliminate, breakdowns. So instead of, I guess sometimes you're still going to run into breakdowns, and you're going to have to, fix equipment that fails that you may have missed. But having a good preventative maintenance program, and this again includes the operators as well as the whole team. The facilities maintenance folks and the engineers. Corrective maintenance talks about improving it. Taking a look at ways that we can improve maintenance on the floor, and then finally, at the facilities level, looking at designing new equipment, bringing in new equipment that doesn't need quite as much maintenance as they had in the past. All right, quality maintenance. This is talking about your product, right? As you're making your product, you want to make sure it's defect free, right? So a good example of this is if you look at let's say a milling operation, right? In a machine shop, you want to make sure that your tools are good and sharp and that they haven't made the end of their life. Because if you go all the way to the end of your life, you're going to start making bad product, and that's not a good way to do. As much as you can, use poka-yoke, mistake proofing, to avoid any potential defects. And of course, it's all about preventing defects at the source. You want to make sure that you make a good part before it goes on to the next operation. Training, right? So this is a key to most things going on in manufacturing, especially in maintenance. You start out and people don't know what to do, or maybe they know what to do, but they can't do it. So you got to teach them. And also you got to follow up with the training to make sure that employees are doing the right trainings they're supposed to be doing. So it's another investment, right? That unfortunately, some manufacturers get too busy and they don't take time to invest in training, but certainly it has to be done. So, if you don't have time internally, we in the consulting area can certainly help you to get that extra bandwidth and get that training done. Office, I talked about this earlier. The office TPM, a lot of times, things happen in the office that create problems on the floor. Really need to have the office cleaned and efficient, and making sure that they're helping out with making sure that the production folks have all the information they need, the material that they need, the tools that they need, and the training that they need as well. And then finally, safety. You know, again, that's one of the pillars of our company. You know, we do safety, quality, and industrial engineering. You got to be safe. You know, you got to make sure that you have lockout, tagout procedures. Make sure nobody's working on the equipment when it's still live. You know, electrically or mechanically. You know, but you have to do the maintenance, right? So just make sure that you're doing it safely. All right, what's the mission of TPM, right? It's to get zero breakdowns, zero abnormalities, zero defects, and of course, zero accidents. All right, so let's talk about equipment effectiveness. Equipment effectiveness is based on maintainability, reliability, availability, efficiency, quality rate, and OEE, which is overall equipment effectiveness. Mean time to repair is talking about maintainability. So here's a little example again going back to vehicles, right? I used to own a Dodge Caravan, and I knew that you know, the life of the transmission was 75,000 miles. So what you don't want to do is decide you want to drive from Long Island to Florida with a transmission it's on its last leg. So, you know, certainly have to replace that transmission, or at least have it really checked out thoroughly to make sure it's running well before you take off on a long trip. So that's the whole idea about mean time to repair. Reliability, actually, I'm sorry, this is the mean time between failures, actually the story about the Caravan. But the same type of thing, you know, you got to look at what's your total running time over the number of failures, and you take a look at the reliability of the process. All right, my computer's stuck here a little bit. Let me just get out of this for a minute and close this out and go back to it. There we go. Okay, efficiency, you got to take a look at the efficiency of your operation. You know, what's the rate of your equipment, what's the speed of your equipment, and that'll give you your performance efficiency. Quality rate, you know, how many good parts do you have out of total number of parts? This is something certainly to look at, and it's another maintenance indicator for you. So if your quality's going down, certainly have to look at that and make sure that it stays way up there. So OEE is basically availability times reliability times quality. All right, what are some of the big 6 losses, right? You got equipment failure, you got setup and adjustments, and another lean technique we take a look at is single minute exchange diodes, which takes a look at setup reductions. Speed loss, right? If you have a component jam, a misfeed, a delivery blocked, it's going to slow down your operation. And then if you have, you know, a piece of equipment that's just rough running, kind of the thought I had before about, you know, if you hear something weird going on in the engine or in the car somewhere, you got to make sure you stop and get that, identify what it is and get it fixed. Same with equipment on the shop floor. All right, defects, right? If you start seeing scrap, if you start seeing, you know, the scrap piling up or rework going on, of course, that's costing you a lot in your production. So you got to make sure you get that fixed. And production rejects, this is more looking at, you know, the QA folks, quality improvement or assurance folks that are kicking things back and saying, hey, we got bad product here. We got to check it out and get it fixed. You know, it's all about continuous improvement, right? So you want to make sure that your trajectory is heading up and not heading down as far as getting better about avoiding the big 6 losses. All right, let's talk about OEE. This is overall equipment effectiveness. That's availability times performance times quality. You see the calculations here. Availability is operating time over total time available. Performance is talking about ideal cycle time divided by operating time, and then quality parts is good parts over total parts. This kind of gives you an idea of areas that you may be looking at with scrap and rework, minor stoppages, etc. So, as the maintenance manager of a facility, you kind of take an overall look of what's happening with your operation, and this would be a good data point to take a look at in your operation. This talks about the graph before, which is basically a stair step, and you want to try to avoid those losses that you see in the stair step identities. Okay, well, if you want to benchmark yourself, what you be looking at, right? Availability should be 90%, performance 95%, quality Six Sigma, right? You're looking at 99.9%, and overall equipment effectiveness is 85%. What's OEE? It's a measurement of TPM progress, right? So if you're trending up again, you're doing well. If you're trending down, then you got to dig into that and find out what it is that's driving your OEE down. Some of the benefits: increased equipment productivity, less downtime, increased capacity, lower maintenance and production cost. You really want to take a look at zero equipment to cause defects. So any quality manager will tell you that zero defects is your ideal, which you're shooting for. And enhanced job satisfaction. People like to be able to, operators like to be able to make good parts, feel good about what they're doing. If they're making a bunch of scrap, I'm sure they're going to be getting a lot of heat from the production manager. They'd be a lot happier if things are going well and they understand what's happening in the process. They've been trained, and they can produce good parts. And of course, from a business standpoint, you always want a good return on investment. All right, here's an example that you could use if you want to do a little calculation and come up with what the OEE is. I think we're going to skip that for today, but that's it for me. Thank you. Any questions that anybody has?
Great. Now I'd like to turn it to Batu. Batu is from our pre-sales software specialist team at American Workflows Enterprise Software Company, AWF. And in this session, he will show and tell about America P3M software system, based on what we just learned in the presentation, which was really informative. Now, Batu will perform a demonstration about America P3M, AI-powered machine health condition monitoring, predictive maintenance, OE, and energy management software. And you can see in action as to how one can perform total productive maintenance management with the help of the software system. Great. Batu, floor is yours. Please show us the system in action. Thank you.
Thank you, Kevin, for introductions. Now let's talk about the America P3M. America P3M's platform offers a modular approach, allowing you to choose from a range of features including energy management, visualization, alarms, machine health, and more. We can tailor the platform to your specific needs and unlock exceptional efficiency in your manufacturing process. Now let's walk through our setup. As you can see here, we have created few factories, each with their designated areas. And within these areas, we have established several production lines that receive real-time sensor data. When you click on a specific production line, as you can see the image of the production line, this is the packaging line. You can also see the organization name, factory name, area name, name of the line. And as you can see, this production line is a discrete manufacturing type. Next to the production lines, we can see our sections. Next to sections, we can see all our assets with their areas inside each factory, and you can see their status as well. When you click on a specific asset, you can see the image of the asset. You can see again with their organization name, their factory name, their area name, and you can see the name of the asset. And lastly, you can see the state of the asset. As you can see with their first state, last state, and if there's any changes in last state, you can see that through here as well. If you want to add a brand new asset, we can do that too. Simply, we're going to click on plus and add button on the top right. Then we're going to type our asset name. For now, I'm just going to call it test. Then we're going to be locating, is it going to be in which area, right? So is it going to be an area or section? So I'm going to go with area. Then which area is in the logistics, water section, waste management, or packaging? So I'm going to go with packaging. Then we have the settings. All the settings are came in default, but we can change them as we like. I'm going to keep enable the auto stop detection, and I'm going to enable the auto stop detection as well. And my auto stop detection tolerance is going to be in 5 minutes. And once I'm all done, I can finish this, click on finish, and that will update my assets. Now let's move to the parts. As you can see, we can see all our parts in the system with their type. We have several types. We have pumps, coupling, AC motor, shaft, belt drive, and so forth, right? Again, if you want to see the image, we can see it, we can zoom in, and so forth. If you want to add a new parts, we can simply click on add. We're going to be choosing, which part has been located, right? So I'm going to go with asset, for example. Next, then we're going to be choosing the asset. Then we can choose the type of the asset. Is optional. We can put the manufacturer and model number as well. After putting all the information, we can click on finish, and that will update our parts. Now let's move to the placements. So placements are the sensor placements. Under here, you can see the placements with their image. You can see which factor they're in. You can see again with the area name and with their asset production line. When you click on a specific placement, you can see it in more detail. Again, with the organization name, factory name, area name, you can see the name of the asset and name of the placement here as well. Now let's move to the sensors. So as you can see, under sensor, we can see all the sensor in the system with their factory. You can see which area they're in which production line, and where you can see the placement as well with their state and battery levels. Let's click on a specific sensor. And as you can see here, this is an example of one of our vibration sensor. Image of it. Under here, you can see the name of the asset. You can see where is the placement. You can see the placement name here too. So this specific sensor is getting the data from the vibration and temperature. You can also see the state of the sensor is all on the below. You can see this specific sensor is first started recording back in September 2022, and the latest records is back in May 2024. And you can also see the battery level for the specific sensor. You also have an option to move this specific sensor too. As you can see, if I want to choose a new placement, I can simply click on the selected placement, and I can choose my new placement here, and it's gonna go, let's just say here. Then if I click on move, that will update this specific sensor's placement. Lastly, we have the gateways. As you can see here, we have two with their state and which area they are in, and you can see the gateways with their detailed information. All right, now let's move to the dashboards. First, we're going to be starting with machine health. Under machine health, we're going to be talking about the machine health anomaly detection. In here, we can monitor the health of your machines to prevent downtime and extend the life of your assets. It's a crucial part of our proactive maintenance strategy. Before I talk about the graphs, let me summarize how machine health works. So we do this by step. First step will be the AI will send warnings when machine degrades in health. So what are those warnings, right? So those warnings are the small orange bubbles, as you can see right here. And the second step will be then we make a work order for that specific problem. And when the work order is completed, technician will check the alarms and its faults. And the last steps will be the machine will run again and the future breakdowns are avoided. So this is the 3 steps that we follow under machine health. All right, so back to the graph. As you can see, this is an anomaly detection for the electric motor. The greens means are good, Orange those are the warnings that AI will send. And sometimes we can even see red in here too, but in here, right now, we don't have any. So only warnings we have right now is this orange bubbles. Above that, we have the health graph for the electric motor. As you can see, this white line is under good, so it's in a good shape. Below that, we can see the RMS and all axes for this specific electric motor, and I can also see my temperature for electric motor as well. All right, now let's move to asset degradation. Under here, I can see the machine health graph and anomaly graph for the asset. And I can also see the vibration RMS in all axes as well. And lastly, I can see my temperature graph here too, as you can see with the line chart. Again, an anomaly graph, with green dots and orange dots as well. Again, orange dots are the warnings that AI will send when the machine degrades in health. And the machine health graph, as you can see, the degradation and timeline with this white line here for the assets inside the system at the moment. All right, so now let's move to the planner, our maintenance planner. As you can see, under the maintenance planner, we can see all our work orders. So in America P3M, we have two ways to create a work order. First is the AI will generate automatic work orders when the machine degrades in health. And the second way to do it is manually. In order to do it manually, we can simply click on the plus work order on the top right. When you click on it, we're going to have to name it, of course. I'm just going to call this test. We also have option to assign assignees to this specific work order that we're going to be creating. Description, I'm just going to call test as well. And I'm going to be choosing my planned start time. Let's call this for next week, Tuesday. And expected end time is going to be next week, Friday, which is the 6th. We also have actions. So what are actions? Actions are the work steps that you're going to be taking for this specific work order, right? So for now, I'm going to leave this empty, but I'll be talking about that in detail in a minute. Now we're going to click on next. Next, we're going to be choosing an entity type. So for this example, I'm going to be choosing production line. After choosing the entity type, we're going to be choosing the entity. So I'm going to go with packaging line. For category, we're going to be choosing what kind of work order it's going to be, right? Is it going to be a repair? Is it going to be a sport maintenance, inspection, and so forth, right? So I'm going to be going with inspection for this example. We also have, option to choose the subcategory as well, but I'm going to leave this empty. Lastly, we're going to be choosing our priority. So it's going to be low, medium, high, or urgent. I'm going to go with high. Our last step for creating a work order manually is adding attachments. So it's optional, but we can, in here, we can add attachments. It can be images or documents and so forth, and we can do that through here. And once we're all done, I can hit on finish, and that will update my maintenance planner. As you can see, I put them between the 3rd of September to 6th. As you can see, this is the brand new maintenance, the work order that I created under the maintenance planner, as you can see right here. All right, now let's go back to this month and let's talk about existing work order, right? When you open existing work order, you can see the name of the work order, and you can see if it is pending or complete. You can see the state of the work order as well. And you can see the description of the work order. This one example is lubricate using the lube oil. You can also see the start and end time date for this specific work order too. On the right side, we have the actions. So actions were the steps that you were gonna take during that specific work order, right? So as you can see here, the first step is checking the motor's model and serial number. And the second step is cleaning the area around the bearing and prevent contamination, right? So these are the steps that the technician will be going for the specific work order. You also have options to view how you want to view the maintenance plan as well. So this is a calendar view. If you want to view as a list, you can view them as lists like this. Lastly, we have the panel as well. You can view them as panels too. But my personal preference, I go with calendar like this. All right, now we're going to go back to dashboards. Then under maintenance, we're going to be talking about our work order overview. So under work order overview, you can see all your work orders in one place. On the left side, we have all the work orders that have currently been pending. In the middle, we have all the work orders that have been in progress. And on the right side, we have the work orders been finished for the last 3 months. It's the same concept. When you click on a specific work order, you can see the name of the work order, the state of the work order, the description of the work order, the end time dates, and end start end date time. You can see under here too. Unless you can see the actions that's gonna be taken for the specific work order on the right side. So this was maintenance, and now we're gonna be talking about OEE. First, we're gonna be starting with packaging line timeline comparison. By the way, OEE stands for overall equipment efficiency. Under the packaging line timeline comparison, you can see the packaging line timeline. As you can see, different colors means like different descriptions. So yellow means, for example, there was a sensor malfunction between this time. And pink means, for example, there was a feeder problems between this date and time, right? And blue was there was a gearbox breakdown. So whatever has been happening inside the packaging line, in the timeline, it will show up in here. Now let's move into the packaging line classic simple OEE and timeline. Under here, we can see our OEE levels, which is 100%. You can see OEE availability, OEE quality, and OEE performance. Again, below that, you can see the packaging line in timeline. And below that, you can see the parallel in packaging line. So as you can see, there was 3 occurrences in machine failure. It's all added here, right? And you can see there was 2 occurrences in reduced yield, and there was 2 occurrences in reduced speed, and there was 1 occurrence in setup and adjustments. So it's all recorded here. Now let's move to the packaging line full overview. So under full overview, we'll see everything. We see the OEE, we see the timeline of the specific packaging line, we see the parallel in the packaging line, and we can see the event logs, and I'm going to be talking about that later in a minute in more detail. You can see all your work orders for that specific production line. You can see the energy usage as well. So I'm going to be talking about energy later on as well. All right. Now let's move to the packaging line OEE overview. So under OEE overview, we can see all OEE, right? So we can see the OEE of processing line, our OEE availability in processing line, our OEE performance in processing line, and our OEE quality in processing line as well. And we can see on the right side, end of line output last 7 days, and the scrap for last 7 days as well. As you can see with their line chart. Next, I'm going to be talking about the packaging line in event registration. Under here, you can see the timeline of the packaging line again with their different colors, and different colors means something different, right? For example, again, with the yellow means sensor malfunction, blue was like gearbox breakdown. We also have an option to put this manually. So for example, I want to add another machine failure, for example, right? I can simply click on plus on event, and I can confirm the log event, and that will update my my timeline packaging line. And as you can see, we have different IDs for different problems, right? There's a problem like ID 2, that was a setup and adjustments, ID 4, that was reduced speed, and so forth. So this is how I recorded manually. Lastly, under OEE, I want to talk about the event logs under packaging line. As you can see, all the events that's been happening, it's been recorded here. So for example, for the machine failure, our first example here, right, ID 1, that in packaging line, you can see in where, so it's going to be in the packaging line, and you can also see the date, right? So it happened today, at this date, and this time. And there was a mechanical failure, for example, right, in packaging line at this date and this time. So like for the summarize, you can see everything that's been happening in packaging line under event logs. All right, so that was OEE. Lastly, let's talk about energy. Under energy, first we're going to be talking about our energy overview. Under energy overview, we can see the machine 1 in 60 minutes. We can see the total energy consumption in machine 1 in 60 minutes. And you can also see our CO2 emissions packaging line for this specific machine 1 in 60 minutes as well. And on the right side, we have the power consumption packaging line graph. All of that is the same machine, but instead of having a 60 minutes, it's a 7 days. So for the machine 1, you can see the total energy consumption for the last 7 days. And you can also see the total CO2 emission in packaging line for the last 7 days as well. And you can also see this in the graph version too. Now let's move to the energy in 5 machines. So this is the same concept, but instead of seeing only one machine, we see 5 machines at one time. As you can see, let's go with the machine 1 again. For machine 1, you can see the total energy consumption, and you can also see this in the graph and a line chart here as well. And the same concept goes with every other machine here. For same thing for machine 2, machine 3, machine 4, and machine 5. Lastly, let's talk about energy production versus standby time. Under here, we have the energy consumption pie chart. Under pie chart, you can see how long the machines are running for, right? It's running for 3 days, 2 hours, 25 minutes, and 47 seconds. You can see the total standby time. So they've been on standby for 4 hours, 60 minutes, and 9 seconds. You can also see the total shutdown time. So they've been shut down for 25 minutes and 47 seconds. On the right side, we can see the energy consumption in whole packaging line, and this is the number. And you can see the whole CO2 emission packaging line as well. And below that, we have the power consumption packaging line graph. Thank you for watching. Kevin, back to you. Thank you.
Batu, thank you very much for the demonstration. As you saw during the demonstration of Batu, you can actually perform predictive maintenance in the scope of total product maintenance management digitally. And with the power of AI nowadays, we are all lucky to use that technology without having any downtime. Actually, we can take actions and address any possible issues in any machinery or equipment. All right, sounds good. So it looks like it's my turn now. So what I'll do is in this session, I'll just briefly introduce AWF, American Workflow Enterprise Software Company, AWF, and then I'll also introduce some more insights about America P3M software system. So let's talk about our company a little bit. As for introductions, American Workflows is an enterprise software publishing and distribution company. And fundamentally, the way that we design our software systems are they are AI-powered, feature-proof systems so that you can use our enterprise software systems for many, many years. Our mission as an organization is to digitize and automate every single business process, every single workflow in the US and anywhere in the world. We do this, we deliver this with the help of our enterprise software systems. We are based in New York and we have global operations. In addition, we have technology partnerships in place. We are an ISV partner of America. We are an ISV partner of QSAN ERP. We are also a Microsoft partner as well as Sage partner. So let's talk about our software systems as to how we deliver our mission, which is to digitize and automate workflows, business workflows in the US and anywhere in the world. Well, first of all, we have a no-code software platform called Workflow America that is designed to help you design any of your business workflows without coding. Followed by, we have another version of the same platform. It's low-code system. So there is drag and drop environment in this platform. And there is coding possibility option also available. So with coding or without coding, we have 2 editions of the workflow platform for your organization. Followed by the marvelous social CRM software system. It's also AI powered. That is designed to help you manage your sales, marketing operations, marketing campaigns, email blasts, SMS text messages, as well as helps you manage your pipelines and sales operations. So it's designed to help you make sale and increase revenue. America P3M is the one that you saw earlier by Batu's demonstration. Is designed to help you manage all your machine maintenance operations with the help of AI in a predictive manner. So you'll have a chance to eliminate any possible downtime at your facilities. And I'll talk about the system a little bit more in my coming presentation session. Also, let's talk about the marvelous APS software system designed for manufacturing companies. APS stands for Advanced Production Capacity Planning and Scheduling Software System. It helps you plan your production operations, helps you address any bottlenecks, update your resources, and you can have a planning session, planning work with the help of the software system digitally. It also automates your addressing your bottlenecks, and you can manage your resources, man, machine, and material to put it together. And with the help of the APS, you'll have a smooth production operation. That's actually what it does. So it's very exciting. We also have QS and ERP systems in our portfolio, both for small businesses as well as enterprise businesses, to help them manage their accounting, finance, manufacturing, construction, real estate operations, as well as warehouse and logistic operations as well. So these are also very capable enterprise software systems. Most of our systems are actually vertical free. Because of that, we have clients in many different industries: aerospace, automotive, food and beverage, energy, and many other industries are also industries that we are active in. We have clients of. All of our enterprise software systems are integratable. So we have integration capabilities in place. We integrate our systems to other finance and accounting software systems. We integrate to IoT devices as well as other business software systems to avoid double entry and to help your systems exchange data to automate your business processes. So in a nutshell, that's who we are and what we do as an enterprise software publishing and distribution company. So now let's talk about AI America a little bit more detail as a follow-up to Batu's demonstration. So as you saw during the demonstration, you can do many different things with the help of AI America P3M to monitor the performance of your machinery equipment as well as performing the predictive maintenance operation. So the system itself comes in 2 editions. So today we saw 1 edition. That is the AI-powered version. That's the one that you saw earlier. As for the AI-powered machine health condition monitoring, as well as maintenance planning, OEE, and energy management. Followed by, we also had the classic CMMS for the AI America. It's an EAM system. It helps you manage your assets, asset life cycle, as well as your spare part inventory. Also, you can manage your team members as for your mechanics, as well as your maintenance crew in your organization. So it's also very, very, very capable system. So we have these 2 editions to address pretty much all the possible needs in the marketplace, both in the AI-powered edition, also the traditional CMMS EAM point of view that we have both of the systems. So as for demonstration earlier, and as for my presentation, we'll focus on the AI-powered predictive machine health condition monitoring and predictive maintenance management part of the edition, the software platform today. So as you saw earlier, the predictive machine health module is actually AI-powered. It actually analyzes vibration based on the vibration of your machinery and equipment. It can actually predict any possible downtime up to 3 months earlier. So you can take action months earlier. So you have a head start, and you will literally eliminate the possibility of downtime when you are monitoring the machine or equipment. What type of machine and equipment could be? So fundamentally, anything vibrates is something that we can listen to, and AI can actually help you with it. It could be bearings, could be compressors, could be HVAC units, could be pumps, electric motors. So these are pretty typical that we have the clients using the system to monitor these equipment and machinery. And benefits are massive. I mean, based on the feedback we get from our clients report that they reduce downtime by 35%. They extend the equipment lifetime by 15%. Also, our clients report that they reduce spare part inventory and purchasing operations. They save up to 20%. These are big savings for any manufacturing organization. And not to mention, the elimination of downtime is very beneficial for manufacturing companies, because each downtime costs thousands or millions of dollars, depends on the severity of it. So in that sense, this system is very beneficial for manufacturing companies. And the good thing is now AI technology is more mature. This is accessible. This is also affordable in terms of cost. And also everything is wireless. I mean, years ago, when the first these technology started in manufacturing industry, there were a lot of wires to be taken care of. Now everything is wireless. So in that sense, that's also in your favor, that it's way more practical than how it was in the past in terms of AI-powered machine health, condition monitoring, and predictive maintenance. The software, as you saw during the demonstration, is very visual. A lot of graphs, a lot of visual tools for your review, and automated with alerts and maintenance planning capability. So the system triggers automatic work orders for you after predicting that something is going wrong with the equipment machine based on the vibration. And AI detects that and lets you know, and you can take action. And also, how do we listen to the machine and equipment, right? That's one of the questions that we always get. So there are two possibilities. The modern machine and equipment that you may have comes with a software. And these software systems are already monitoring some vitals of the system, vibration, humidity, temperature. So we can integrate to the software of your machine, and AI can take it from there. That's one option. Other option is if it's just electric motor, if it is just an HVAC unit bearing, you may not have a software. Then just like the one that I'm sharing on the screen right now, you may have electric motors, for example. Then we offer you the sensors. These sensors are stick-on sensors, screw-on sensors, as seen with the yellow arrows. So these are non-invasive. You stick them on your equipment. Everything is wireless. So we also have a wireless gateway, and via the wireless infrastructure that we have, other Wi-Fi or 4G or 5G, we can collect the data. This is it, pretty much. All you need is 2 sensors, wireless, and a gateway. And gateway can actually work with many sensors. So you just need more sensors for other equipment and machinery if you like to monitor more. But you can start with one equipment. We are okay with it, and we definitely welcome it. Starting with the mission critical equipment is very important to start benefiting from the technology, at the earliest, as well as getting used to the technology, and then you can expand from that. You can add more equipment and machinery if you like, optionally. It's up to you. At the same time, it's a pretty good example of how we set up things. If you have more sensors in your organization, we can help you set this up, and then wirelessly, digitally, we can collect the data of vibration, and then AI kicks in and gives you heads up to 3 months, 90 days earlier. This is a big advantage that will allow you to take advantage and enjoy it in your operations. Great. So in that sense, that's a pretty mature system with AI-powered capabilities. And also we have as part of the system as a maintenance planner. So anything AI predicts, it also triggers automatic work orders, or you can set up your work orders manually. It comes with a nice calendar, as demonstrated earlier by my colleague. And with the calendar, you can see what is scheduled for today, what was scheduled yesterday, what is coming up in coming days, months. So it is very popular among our clients. Most of them, they put them on the large screen and now follow from there, for example. And the work orders are also very detailed, as you can see that you can set up and schedule. If you have an existing EAM system or CMMS system, you can just get the AI module, the one I just showed earlier, and then you can integrate it to your CMMS or EAM system that's already existing in your organization. If you have no CMMS or EAM, you'll enjoy this system, this part of the system, because you can also take care of your maintenance scheduling at your company. OE module is also very critical. Doing both presentations earlier, the overall equipment efficiency is a very popular subject nowadays, as much as it's also very important among serious manufacturing companies. So our system helps you capture data with regards to the capacity of your machinery equipment, the outcome of your machine and equipment, and your production operations. And it shows you overall your rating as for overall equipment efficiency, performance, and other vitals that you can monitor. And you can actually analyze, and you can take managerial actions to improve. In that sense, it's also very beneficial for your company. If you are compliant with ISO 9001, as per the ISO philosophy, that's how we designed the system based on ISO, and continuous improvement is the backbone of ISO 9001 and also any quality management system. So the OEE module is to help you monitor your performance, overall equipment efficiency, as well as gives you an opportunity for continuous improvement. This module also comes with many different graphs and visual tools, as shown during the demonstration, and you can improve many of your operations. This is good for both for discrete manufacturing as well as process manufacturing, such as food, beverage, chemical, dairy and other types of process manufacturing operations. So in that sense, any manufacturing company can use and enjoy the benefits of the system. Energy management module is to help you capture your consumption as for electricity, pressure, gas, water, and also we help you calculate your carbon footprint, right? So if you are an organization sensitive about energy consumption and also savings on energy, as well as if you have ESG reports or if you are compliant with ISO 14000 in terms of environment, for example, then this module is for you to have and monitor your energy consumption, analyze, and helps you find ways to reduce energy consumption in your organization. So in that sense, it's also a very capable system. It comes with, as you can see, with different graphs and visual tools for you to see what is the consumption, what is the carbon footprint, possible savings, and so on can be seen in the system. In that sense, it's a very exciting platform. And we also provide hardware to monitor your energy consumption if you don't have any infrastructure. So we have the alerts in the system. These alerts come in email as well as visual tools that you have in the system. Also, you can have also alerts within the system as well, so you'll be notified no matter what. The notifications comes from the AI powered machine health condition monitoring module. Also triggers automatic work orders to automate it. So it is also very, very beneficial and user friendly in that sense. Integration is always an option. So we, as I mentioned earlier, we integrate our system to typically existing CMMS systems or EAM systems. If you have one already operating that you are happy about, we can integrate so you can have the linkage between these two systems. So our system helps you see what is going on and helps you see the predictions of the AI, and also your traditional CMMS can take action for maintenance management if there's any. If you have no CMMS or EAM system, we already have maintenance management module available in the software system. In addition, we have another edition of the software system called America CMMS. That's a traditional CMMS and EAM system as well. So you have a lot of options that we'll be happy to discuss with you, your company's expectations as well as requirements, and we can help you find the best setup for you with integration, without integration, which is going to be the easiest, most practical, most cost-effective option for you. We can discuss and help you make the right decision, and we'll be happy to work with you. All right, great. So far we covered a lot of subjects. We talked about the total product and maintenance management practices and fundamentals of it. We also performed the demonstration of America P3M software system, and I took the chance. It was my pleasure to also introduce our company, American Workflows Enterprise Software Company, AWF, and also I introduced more information for you with regards to America P3M software system. Sounds good. So it looks like a wrap up. Before we end these, I'd like to invite you to our YouTube channel. We have American Workflows YouTube channel set up. In YouTube, we have hundreds of videos, and more are coming on weekly basis. So we are very excited about it. We cover the subjects of digital transformation, manufacturing 4.0, cloud technology, predictive maintenance, as well as task automation, document management, and accounting and finance management in the age of AI. So please visit our YouTube channel and subscribe so we can keep you updated and we can enjoy our informative videos. I'd like to thank you for your time and for your interest in this executive webinar session, and looking forward to having you in coming webinar sessions. Thank you very much and have a nice day.
Thank you for attending the executive webinar session. For more information about American Workflows Enterprise Software Company and its enterprise software products, please visit the corporate website at www.americanworkflows.com. Looking forward to seeing you at future executive webinar sessions of American Workflows Enterprise Software Company. Have a great day. Thank you.